Right. Supplementary physical quantities. So we're having supplementary physical quantities only two. So let us take now. These both physical quantities are dimensionless quantities. So what do you mean by the dimensionless quantities? So once we will study what is dimensions. So by the time you'll understand. So let us take supplementary physical quantities. The first one is angle or plane angle. First one is angle, or basically we can say plane angle. You might be remember mathematics will study two-dimensional and three-dimensional objects. Do you remember everybody? So supplementary physical quantities, the first one is angle, which basically will say how many dimensions? Two dimensions or three dimensions? Two dimensions. Clear? If I have taken, I am saying plane angle. What do you mean by that one? Suppose if I have taken, this is the plane, and if I draw the arc like this. So angle between this one, we used to say, definitely what is this called as? Theta. Is it yes or no, everybody? Yes, please. Now, I will draw one arc here. Now, what is this theta? Theta is equals to, keep in mind, all of you, theta is equals to arc divided by radius. So that is what radius means what? Do you all know radius? Yes or no? All of you? So that is what the theta. For,
Yes, sir.
for plane angle, we will measure theta is equals to, this is the arc. This is the arc. Keep it in mind, everybody. Clear? So please note down. Completed? Yes? Understand, brothers? So, under radius. What is the radius now here? From here to here, what we used to call it? Suppose I consider this is the arc, brothers. This is the arc. So, what is the radius? This is the radius. Understand? And this is the arc. So, what is the theta? Theta is equals to what? Theta is equals to arc by radius. Now, if I consider very, very small angle, like if I can say, like future, you'll get it differentiation also. So that I will write it instead of theta, I will write it as a d theta. D theta is equals to this arc, I will consider as a ds, because arc is a what actually? Length only. Yes or no? So I will consider as a ds. So d theta is equals to ds divided by r. Are you clear? So this is what you can learn. Remember this also. Theta is equals to arc by radius. So the unit of this one is radians. What is the unit of this one? So Rudreswar, radian is the unit. Now this is the first time you people might be heard. Till now you might be seeing angle used to measure in what? Degrees. Yes or no, guys? Yes. For those. Yeah. Now the
Yes,
unit you are
sir.
going to get it what? Radian, and the symbol of this one is called RAD. This is the symbol. So this is the first supplementary physical quantity you are studying. So that is what we can make. So there are, you after basic 7 quantities, this is the next one. Next, you are going to study after this one is three-dimensional. That is what solid angle we can say. So you can take any kind of solid angle if you have taken. So solid means how many dimensions, guys? It will be 3 dimensions. So let us consider now cone. So we all people knows. Let me consider this is the cone having a area of cross section A, and you might be see cone means it will be like imaginary 3-dimensional. Yes or no, brothers? So you can imagine just it is a 2-dimensional one. So you can imagine a 3-dimensional. Let me take having a radius of something r, and it will be like imaginary line. I'm drawing because it appears to be how many dimensions? It will be a 3 dimensions. Clear? So having a radius, now we want to find this theta. So here the theta is equals to, keep it in mind, theta is equals to a divided by square of radius. Are you clear? Yes, please. Pradosh. So sorry, square of radius. This is what R, keep it in mind. This is what we used to call as R, okay? Radius from this point. From this point, this is the R and this is the area. So theta is equals to A, area of cross section divided by radius square. Radius square. Clear? Yes, please. And the center, which we used to call as actually apex. Apex, which will represent with the O. If you want, you can represent. It's nothing is there. Clear? Understand? Yes, please. So this one you can represent even with omega also. This theta basically we can represent with omega also. If I take omega, omega is equals to A by R square. Or if I represent in the form of differentiation, very small, keep it in mind. If I have taken this is big part. Like I am considering a very big cake. Now I am considering extremely small part. So small part means what is the English word we'll use? We'll use a differentiate. Is it yes or no, guys? Basically, we'll say separate it or not. So in physics, we'll use, if you want to like segregate into small parts, we'll use a word called as differentiate. So differentiate means I'm considering how much parts? Extremely what part? Very small. Then theta, d by this omega is equals to, instead of A, I can take what, guys? I will take it as a dA divided by R square. So dA is a what? Extremely small part I am considering. So this is what for 3-dimensional solid angle. So 2-dimensional solid angle, arc by radius, 3-dimensional solid angle, area of cross section divided by radius square. So the SI unit of this one, keep in mind, the SI unit of this one. What is the SI unit of this one? Stay radian. So symbol is SD. See, 2-dimensional, what is a unit? Radian, and 3-dimensional stay radian is the unit of this one. So what is the symbol? SD. And remember, this both quantities are radian and stay radian. Both we used to say they are what actually? They are the dimensionless quantities. So what is dimension? We are going to study now. So just remember, both radian and steradian, the symbol is, one is radian is R and steradian is, I have written SD. You can represent with this is actually shortcut, and we can represent with even SR also. SR, steradian, you can write it also. So nothing is wrong there. So both these are dimensionless quantities. So what is dimensionless? You will understand it. Okay. So keep it in mind. This omega, d omega or theta means what angle? Plane angle or solid angle? Everybody, it is the solid angle at the apex. Apex means that point, the cone. And this is, we can say, angle, plane angle, we can say. It's the 2-dimensional and this is the 3-dimensional. It's okay, everybody? Yes, please. Now, I introduce a new thing to you people. Till now, you measure the angle with only degrees. Now, you are studying new thing. What is the angle we are measuring here? Yes, radians. Unless you don't know, you know this, you people cannot solve measure many numericals in this chapter. So, keep it in mind, we all know what is the maximum angle. We know 360 degrees. So, 360 degrees is equals to 2 pi radians. Learn this. Next, 180 degrees is equals to pi radians. Same way, 90 degrees is equals to, you might understand by this time. Can you tell me, Mr. Udreswar, how many radians?
Pi by 2 radius.
These are the very important relations which will help you for us in numerical style. So make it fast. 360 degrees, 2 pi radians. 180 degrees, pi radians. 90 degrees, pi by 2 radians. So it is over. Now we are going to enter into the most important one. Based upon this only, surely the question will come in NEET, JEE, and as well as board exam. That is what? Dimensions. So what do you mean by this dimension? Let us understand it. First we'll write the dimensions of fundamental physical quantities. Later automatically you people will understand what is dimensions. So what is the fundamental physical quantities? Fastly tell me, everybody. What is the fundamental physical quantities? One is length.
Length.
The dimension of length is L. Keep it in mind, I am writing bracket. Keep it in mind. What is the length dimension? L. Next, mass. Mass dimension is M, capital M, bracket. Next, time dimension is capital T. Keep it in mind. Not symbol, Rudreshwar. Do you understand? Dimension. You'll understand what
Yes,
is it. Next, temperature. Temperature is, what is the symbol? Temperature unit. SI unit of temperature. Kelvin. So
Kelvin.
represent with the K or theta. Everything I will teach you. I am not going to make anything to you beginning. Electric current. Electric current, what is a unit? Electric current.
Ampere.
Ampere. So dimension is also capital A, bracket. Luminous intensity. You all know luminous intensity. What is the expected dimension? Can you tell me? Speed of light in air. That is the same dimension. Yes, please.
C.
C. Next, amount of substance. We all know amount of substance means which physical quantity?
Mole.
Mole.
Yeah. So that is what MOL. Clear, everybody? And in this, remember, most important dimensions is first three. That's why I written with red pen. Most commonly used dimensions. We will solve now. You will understand. Most commonly used dimensions. Now I will teach around 10 and I will stop. Anyone having any doubt, you have to ask me. From there only we will continue further. Is it okay, everybody? Yes, please. All of you? Right. Definition of dimensions. Definition. Dimensions are the powers. Dimensions are the powers. When we are writing, you will understand the definition also. Dimensions are the powers. Very, very important concept, this entire chapter. To which the fundamental units are raised in order to express derived unit of quantity. Now, I hope you all understand the meaning of it. Nothing is there. We are using the fundamental physical quantities are raised to express what actually, guys? To express what? To express the, everybody, derived physical quantities. Do you understand, Laksha? Now, when I write one or two, you will understand it. So let us make first derived physical quantity. Can you tell me what is the first derived quantity we studied, Pradosh? Just what is the first derived physical quantity? Check your notebooks and tell me. Yes, please. Area. Correct. Now, can you guess what is the area of dimensions? Dimensions of area, please. Area, what is the unit? Square meter. Okay. So L into L, length into length. So powers we can add. What is the dimension, Pradosh? L square. Clear? Because beginning, so that I am writing little in detail. Later I won't write. You should tell me fastly. L square. Now, is there any mass and time? As I told you, what is the basic fundamental quantities? Most commonly used one. Who are that? Length, mass, time. Now, in this area, is there any mass?
No.
No. So, m power 0. Understand, Mr. Rudreshwar?
Yes, sir.
Length, L. What is the power of length? 2.
0.
2. Length.
Yes, sir. 2, sir.
What is the power of time? Laksha?
0.
0. So, whenever you will get this dimensions, it is indicating which physical quantity? It is indicating which physical quantity?
Area.
Now you go back to the definition and read. What is the definition? Dimensions are the powers to which the fundamental units are raised. Have you noticed the powers? What is the power of m here? Power of m? 0. Power of L? 2. Power of time 0. So this is the dimensions which is representing the derived physical quantity by using which physical quantities? Fundamental physical quantities. Who is the fundamental physical quantities here? Mass, length, next what?
Time.
Time. Understand, Mr. Rudreswar now? Next.
Yes, sir.
Let it write for volume. I will teach more than else. Later you can practice even still if you want also. Your book you are having more than 150. Length. Can you guess what is the Pradosh? What is the physical quantity?
L
So
power 3.
dimensions. L power 3. But you should not write this. This is not the dimensions. Understand, Mr. Rudreswar? This is the dimension. Clear?
Yes, sir.
Yeah, because why I'm writing L3? Because volume means we can get it what? Length into length
L
into
into L into
length into length into length. Pradosh, do you understand, Pradosh?
Yes, sir.
Dimension means nothing, Pradosh. Just we are representing the derived physical quantities in the powers of fundamental physical quantities. That's all it is. Clear?
Yes, sir.
Yeah. We are expressing the derived physical quantities by making the fundamental quantities in the form of powers. That's all it is. Clear? That is.
Sir.
So now, what is the dimensions of volume? Tell me fastly. Laksha?
M power 0, L power 3.
M0, L power 3, T power 3. Clear? Everybody? Next. Third one. Let me take, you can take mass density because I can say density, but it's a correct word, suitable word is called as mass density. So what is the formula of mass density? Fastly. Mass density. Density formula.
Mass by what?
Mass by volume. What is the unit of mass for those?
Kg by
What is the unit of volume?
cubic
What is the unit
meters.
of volume? Yes, please.
Cubic.
Yes, please. Nothing. What is the unit of volume? Cubic meter. Clear? So, write in the form of mass. Here nothing is there means power. What is that? How much it is?
1.
1. So, can I write this one as m power 1 divided by L power 3? Is it right or wrong?
Yes, sir.
Sir.
But I cannot write in the form of like this division. So finally I will modify like this. Anybody can tell me fastly. M
M
power
power 1 into L minus
Power minus 3.
L power minus 3 power what?
0.
E power 0. Clear? Understand those? Mahalakshmi? Next. Velocity or speed. What is the formula I said? Velocity or speed. Keep it in mind, speed means distance by time. Velocity means displacement by time. Both, what is the symbol? Distance or displacement. Both the symbol is what?
Yes.
S by T.
So what is a S? S means we can measure what? Meter per units, guys. Meter
Meter per
per
second.
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 Even units I should not say. You should tell me fastly. Meter per second. So meter means what is the dimension? L. S means what? No one will answer.
Time.
Time. So what is the dimension? L
M power
power 1 T power minus 1.
Minus 1.
But if you have taken as we representing, what is will come? M0 L power 1 T power minus 1. Everybody understood? Laksha? Yeah. Next. We all knows acceleration. So what is the formula of acceleration? Fastly. Acceleration means what?
meter per second square.
Acceleration means final velocity minus initial velocity by time. Do you remember those 9th class? Final velocity. This is initial velocity divided by time. Do you remember or not?
Yes, sir.
Yes. So what is the velocity unit? Unit of velocity, meter per second. What is the unit of time? Unit of
Second.
time, second. So if you have modified it, what is the unit for those? Meter per
Second square.
second square. So meter means what is the dimension? Nothing is there means 1. L power 1 divided by T power
2.
2. So if you write the dimension fastly, what will come?
M power 0.
M power
L
0,
power 1.
L power 1, T power
T power
minus 2.
Minus
Keep in
2.
mind. Now, meter per second square is also unit of some other thing, which will come in gravitation chapter. Can you tell me? Acceleration, we will also represent with, suppose if this is acceleration, A also I can represent with a G, small g. Can you tell me, Pradosh, what is G? Acceleration.
Gravity. Acceleration due to
Yeah, acceleration due to
gravity.
gravity. So if you have taken, for that also, what is the dimensions? Directly you should say, you should not again solve. No formula. No
M power
formula
G.
for acceleration due to gravity. You cannot go and you cannot solve. Of course, formula is there, but result is very, very big. You cannot solve. So what is your dimensions? If units are same, dimensions also what?
Same.
Please. Dimensions also same. So what is the units of acceleration due to gravity? m0, L power 1, T power minus 2. So here you have to remember one statement. What is the statement you have to remember? If units are same,
Dimension
same,
for
what is same? Dimensions are same. Clear? Aksha, that is what you have to remember. Next, let us take force. We all know force. What is the force formula? Just now we studied. Mass into
Mass into acceleration.
mass into clear. Now, can you tell me the dimensions? Let me take mass means kilogram, acceleration means meter per second square. So dimensions fastly. Yes, please. M power 1, M power 1, L power 1, T power
minus
T power. Clear, everybody?
yes, sir.
Yes. Doubt? Next. Let me take momentum. We all know momentum. Class 9th we studied. Before studying the Newton's second law, we studied first momentum only. Formula for momentum, please. Momentum equals to. Saying S is easy. You have to prove. Momentum equals to mass into velocity. Now tell me the units fast. Kilogram into meter per second. Dimensions, please. Fastly. M1, M1, L1 by T1. Write it fast, dimensions. What will come? M1, T1, M1, L1
T power
T power minus 1.
minus 1. Clear? Yes, everybody? Next, work or work done. What is the formula for work? Work equals to force into
displacement.
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 Now, we all knows already force. Dimensions of force. By this time, you should tell me. Dimensions of force, please. Dimensions of force. M1, L1.
T power minus 2.
You should learn it. That's what I'm saying. See, dimensions must be in our tongue always. So, M1, tell me, what is the dimensions of force? M1, L1
L1 T power minus 2.
into displacement. Displacement, what for those? L power? L power 1. So, modify it. What are the things will come? M1, L
L1
power
L2 L power 2.
1. How much? L power
2.
T power minus 2. So, what is the difference between work and force? Dimensions. Work force is M1 L1 T power minus 2. But work is M1
L2
L2 T minus 2. That is the difference. Now, if work is acting parallel to the direction of displacement, we know what is the formula? Work is equals to force into displacement. Now, if suppose I am applying the force in a particular angle, suppose displacement is like this, force is like this. We all know work done formula. Class 9th I taught you. Work done is equals to F into S into cos theta. Remember, Pradosh?
Sir.
Yeah. F into S into cos theta. Can you tell me now what is the dimensions of work? Sudeshwar, be smart and tell me. Can you tell me the dimensions of? Can you tell me dimensions of what is now? What is? Guess what? Now also dimensions are what? If work is equals to force into displacement, or work done is equals to force into displacement into cos theta, then also dimensions are same. M1, L2, T minus 2. Why, sir? Let me take, as we all knows, cos theta. Cos theta is actually what, guys? It is a what? Angle. Correct or not? Everybody? Suppose I will take theta is equals to 90. Then cos 90. Cos 90 is equals to what?
0.
0. So 0 is a number. number does not have, is there any units for any dimensions for number? We have written any dimensions for number? Please respond.
No,
Whatever
sir.
it is, if it is cos 30, cos 30, cos 60, cos 45, definitely we are getting some value, correct? 1 by 2 or 1 by root 2 or root 3 by 2, something we are getting value. So this constant does not have what? Constant does not have dimension.
Dimension.
So cos theta have any dimensions? No dimensions. Clear, Mr. Rudreshwar? So still either work done is equals to force into displacement or force Fs cos theta. Still what is the dimensions? M1 L power 2 T power minus 2. That's all. Clear? Now onwards, more tough things will come. Next, ninth one, power. Can you consider power? As we all know, power. Power P is equals to 10th class also came. You should tell me. Work done by time. Work done by time or energy by time. Just now we studied work done unit. Fastly. M1 L power
T power minus.
T means again T. Yes or no? Yes, Mr. Pradosh. Now, what is the dimensions? Fastly. M1
M power 1, L power 2,
L2
T power
T
minus.
minus T minus
3.
T minus 3. Clear? Everybody? No one will answer. Understand, Ra? Next. Laksha, understood, Laksha? Next. Yes, Pradosh? Tell me. Ask me. Doubt means ask me. Why hesitating?
Sir.
T power 1 will come up. It will become T power minus 1. Yes or no? Say yes or no.
Sir.
Yeah. So now minus 3 will come or not, Pradosh? Okay. Now, can you, if you are very smart, can you tell me what is the dimensions of energy? Let me see who will say. Because I am not giving kinetic energy. Then formula you have. Potential energy, you have a formula. But you don't have a formula now. I'm not saying particular type of energy. It's just a common energy. But I want dimensions. Let me see how smart you are. Yes, please.
Sir, power into time.
You can take power into time. Very good. Of course, without that also we can say. Of course, very good, Dreshwar. You did very nice. From class 10th, he used a mind called as power into time. So that's fine. Again, power is equals to M1 L power 2 T minus 2 into time means T power 1. So that again you will get that dimensions M1 T power 2 T power. Oh, sorry, this is 3, correct?
Sir,
3.
minus 3.
Yeah, minus 3. So minus 3 plus 1. How much, guys?
Minus 2.
Minus 2. Minus 4. Rudreshwar.
2, sir. Sir, 2 only,
Minus
sir.
2. Now, without that also I can say, have you noticed it? How? Before you have written one statement. What is the statement here? Read it. Acceleration and acceleration due to gravity. What is the statement you have written? If units
Same
are,
unit, same
yeah,
dimension.
if units are same, then what is same?
Dimensional formula also.
Then dimensions are same. Yes or no, Pradosh? Now, units of energy and units of some other thing is same. Just now we studied. Anybody? I modified it. Units of energy and units of work, both are what? What is the SI unit of work and what is the SI unit of energy? Both are. What is the unit of energy, Ra?
Each.
Joules only. So we know dimensions of work done is what? M1 L power 2 T minus 2. So then units of energy is also what? M1 L power 2 T minus 2. Is it okay, guys? Anyone having any doubt? Let me know. Clear?
Sir.
That's all. Understand? Now I will say kinetic energy. Now let me see. Don't think about anything in mind. I am particularly mentioning about EK, kinetic energy. What is the units? Whatever it is doesn't matter for us. What is the unit of, ultimately what is the unit of kinetic energy?
M1 L2 T power.
Ray, I am asking unit for those. What is the unit of kinetic energy? Joule.
Joules.
Then what is the dimensions? M1, L power 2, T minus 2.
Power.
I am asking potential energy. Then what is the dimensions? Again units are joule. Then again dimensions are what? M1, L power T minus 2. L power 2, T minus 2. Because any type of energy doesn't matter for us. What is the unit of energy? Yes, please. What is the unit of energy?
Joules.
Joule. Then is same dimensions. Next, first time you are might be heard it is, that is what? If large force is applied in a small interval of time, keep it in mind, large force is applied in very small, very small interval of time. Interval of time we is to called as impulse. We is to called as impulse. So you might be understand what is the formula. Can you tell me impulse means? Definition itself will be having. Definition means what is that? Impulse means force into small interval. Small intervals, how I represent? I told you before. Small intervals means you represent what? Change in time. That is what delta t we can represent. So which is equals to dimensions, please, fastly. What is the force dimensions? M1, L1, T minus 2.
T power minus 2.
Small timer, big timer, change in timer, whatever it is. Delta t. Delta t means what? T power 1. So if you make it, so what it will come, guys? Anybody? Yes, please. M1, L1,
T power minus 1.
T power minus 1. So that's all. So till here you solve. Then from here we will continue. So tomorrow onwards, then tomorrow's class we will continue with the remaining things. Definitely you will understand. A lot of things will be there. So this is what about all the things. I hope you all understood. So from here, so many physical quantities are there. After that, then we will proceed further and we will continue. So once it will take tomorrow's class maximum, we will finish these dimensions, and later we will go for the finding the dimensions of a given algebraic equations. That is what principle of homogeneity. Later only you will understand the things and all. Okay. So hardly tomorrow we are going to maximum finish these dimensions, and then we will go to the applications of dimensions. So from there a real chapter will start. Is it okay, guys? Is it interesting? Sudhir?
Yes, sir.
Yeah, good. So this is what about it. So this is of today's class. I'm going to end now. Then from here we'll continue tomorrow. Thank you, everybody. Have a take rest and get ready for tomorrow's class. Thank you, everybody. Bye.
Thank you, sir.